analysis to find the hydrodynamic derivatives of a hull board and the resistance of a hull. We have done these 4 experiments: the resistance of a 2D board, 3D board, and the sway and yaw force of the yaw moment of the 3D board, and performance of a propeller.
Who is your guide?
Was there Lakshmi Pati was there. Our friend will explain about the 2D board resistance.
Good morning, everyone. My name is Jaswanth. I have done my internship. I have done my internship program in IIT Madras under Professor Vasudeva. My topic is about 2D ship resistance in multiphase. Actually, this simulation aims to evaluate the hydrodynamic resistance of a 2D ship hull in a multiphase medium under steady and state conditions, where we have taken the geometry in the ANSYS design modular, and we go through the meshing phenomenon, which we have done the meshing using UDF functions, which is called user defined functions, which is used for at the edges to get the fine meshing pose of the geometry. Where the simulation utilizes the multiphase flow model with specific boundary conditions and initialization settings to stable and accurate results, where we have used for the multiphase like in water as well as the air medium while the ship is traveling. The first one is multiphase model, which is used as a top region as air, bottom as water, simulating free surface interaction between the water and the ship hull. Second one is pressure inlet, which is used to define water level and free surface height accurately and precisely. Third one is pressure outlet, which we have maintained some water level downstream for stable flow. And the fourth one is initialization. The standard initialization with a scale time factor of around 0.1 for stability phenomenon. And we have done iterations of about 200 iterations to get the convergence and to get the iteration. For 2D hull, we get the geometry, and after going through meshing and some physics model like using RAMS model, after that solve the settings, and we have gone through this graphical representation which describes about the contours, values of the ship hull resistance. We have obtained a value of around 16,276.7 newtons resistance by calculating the 2D hull resistance sheet. My friend is.
Here we have found the resistance of a 3D board using ANSYS. This was the geometry of the board. We have taken the domain, a larger domain, to create the fluid, and here we have taken axis symmetry because the board was symmetry about XY plane. So here we have taken axis symmetry. Here we have taken a force mesh which was part to the board and taken final mesh near the interface between the water and the air. Here we have taken volume of fluid to make multiphase flow. That makes that water at the bottom and the air at the top of the board. Here I have taken turbulence model which uses K omega SST model. This was used for the 3D board. I have taken the boundary conditions as pressure inlet, velocity inlet, which has 2 meters per second, and pressure outlet. have made the initialization with scale factor of 0.5 to make the interface very calm and less waves. I have run up to 200 iterations, which given me convergence to the board. This was the resistance of the 3D board, and this was the cone. The bottom part shows the water, and the top part shows the air. I have taken airy Stokes wave theory for creating these waves. This was to calculate the sway force and yaw moment of the 3D board. Here we have shifted the board to different angles to calculate the sway force and yaw moment. This was the results obtained at sway force 15 degrees and yaw moment with 15 degrees. I haven't got the remaining. I have done this experiment at 5 degrees, 10 degrees, and up to 30 degrees, but those information I haven't got from my professor. The sway force and the yaw moment at different degrees shows a graph which shows the hull hydrodynamic derivatives and hull forces. They say that how our hull reacts at different angle of our how our hull reacts at different angles. Next one is finding the torque and thrust of an iron propeller.
Charlie.